Alright, this is 5.4 problem number 7, probably the trickiest problem from 5.4 that I could find. It stumped me. Alright, so find dy dx for this function y equals x, integral from 2 to x squared of cosecant t squared with respect to t. Alright, the first trick here is, remember, if we have a constant, that's good. If we're going from a constant to a variable, that's good. But this is x squared. We don't want x squared. We want a variable, just to no power, to the power of 1. So immediately we're going to do a u substitution and say, let's set u equal to x squared. And by logic, it follows that x would equal square root u, right? Because we could take the square root of both sides there. And so now I can substitute in here that y equals x is the square root of u from 2 x squared equals u, so we substitute it with u, cosecant t squared dt, and we want to look for dy dx. Well, we can write dy dx using the chain rule as equivalent to dy du times du dx. So that's what we're going to do. And if this is y, then dy du equals the derivative with respect to u of this expression, because ddu of y is the same as ddu of this, so we're looking at ddu of u under the radical from 2 to u of cosecant t squared dt. So we're taking the derivative of y with respect to u times du dx. Well, du dx, we can take the derivative up here where a substitution took place. Derivative of u with respect to x is 2x using the power rule. And so we'll just multiply everything in here by 2x once we're finished with it. Okay, now here's part of why this problem is tricky, is because you might look at this and go, well, d du from 2 to u, I should just be able to replace the u, right? Well, unfortunately not, because if this square root of u wasn't in there, you could go right ahead and just plug in u where t is. But because the square root of u is here, we have to respect the product rule. So to do that, we're going to have to do first d second plus second d first. So first would be square root of u. D second would be derivative with respect to u of the integral from 2 to u cosecant t squared dt, plus, so first d second plus second, which is just 2 to u cosecant t squared dt. So second d first. Derivative of u to the 1/2 is 1/2 u to the minus 1/2. And then this whole thing needs parentheses around it, and we're going to multiply it by 2x, which represents du dx. Alright, so here's where we're at. We can simplify a little bit. Now we'll look over here in d du from 2 to u of cosecant t squared dt. We can use the first part of the fundamental theorem and just replace, because this is a constant to a single variable, therefore we can replace what's inside this function of t. We can just replace it with u. So du of the integral from 2 to u of cosecant t squared dt is equivalent to cosecant of u squared. So we just replaced t with u there. And then of course we have square root of u. I'm going to write it as u to the 1/2. Let's multiplying in here. Alright, and then we're going to add that to, let's see if we can simplify this. Well, 1/2 u to the negative 1/2 can come to the front. And then we're still left with this integral that we can't really solve. And then once that's over with, we need to multiply 2x into everything. Okay, now we're going to go back and replace everything that has a u for what it represents in terms of x. So u is x squared. X squared to the 1/2 is just x. So we have x cosecant. U is x squared. X squared squared is x to the 4. Plus, and then this one's a little tricky, so u to the 1/2 could be written as 1 over 2 square root u, right? 1 over 2 square root u. Well, u is x squared. Square root of x squared is x. So we end up with 1 over 2x times this integral of 2 to u of cosecant t squared with respect to t, and then we're multiplying everything by 2x. So we'll factor that in, FOIL it in. 2x times x cosecant x to the fourth is 2x squared, right? X times 2x is 2x squared, cosecant x to the fourth. And then these cancel. 2x times 1 over 2x is just 1. So we've got plus just this integral, 2 to u of cosecant t squared dt. And remember, this is all equal to dy dx, which is what we're solving for. So at this point, you can plug it in to MyMathLab. And they write in quite a bit of it as a hint. But let me go ahead and enter it in and make sure we get it. And under the integral, we've got cosecant of t to the fourth dt. Let's see if it likes it. Oh, it doesn't like the integral. Huh. Alright, let's see here. 2 to u. Oh, I see. This is 2 to x squared, right? Because u is equal to x squared. It's cosecant t squared. That's what it is. It's not t to the 4. Okay, cosecant, I plugged it in t to the 4. Cosecant t squared, and it likes it. Cool. So yeah, very, very tricky problem. We need u substitution and a whole bunch of other algebra tricks. So hopefully this helps, and I'll see you next video.